sometime ask question, write unbalanced, define unbalanced transportation problem or short note on unbalanced transportation problem, or sometime ask how to convert one unbalanced transportation problem to balanced transportation problem. So you see this theory portion, because earlier I have given all the problems are balanced transportation problem. So how to check balanced transportation or unbalanced transportation problem? This is depend upon availability and demand. Right? Means suppose in sum of row wise and column wise, you see, suppose demands are given, sum of the demands and availability is given. So sum of the availability, these two are equal, then this is balanced transportation problem. And what do we mean by unbalanced transportation problem? So you see, a transportation problem is said to be an unbalanced transportation problem if the sum of all available amounts, means quantities, is not equal to sum of all requirements. Okay, requirements means demands. Sometimes what happens, in place of demands given requirement, and in place of availability here given supply. Okay, so here you see we denote this. One is denoted by AI, means, and another one is denoted by BJ, right? So here suppose 3 row, then A1, A2, A3, 4 column, then B1, B2, B3, B4, like this. So summation AI, I varies from M, not equal to summation BJ, J varies from 1 to N. So if these are not equal, then this is called the unbalanced transportation problem. Means here if sum of all available amount is not equal to sum of all requirements. One is this one. Next, what happened in the transportation problem? You see, we solve the transportation problem. There are methods. One is northwest corner rule. Second one is lowest cost entry method, and third one is unit cost penalty, or this is called the Vogel's approximation method. For getting optimality in your exam, not mention, only solve the transportation problem given, then you always solve it by Vogel's approximation method. Why? Reason is what? Because this gives us optimality, this gives us the optimal solution, means this is nearer to the optimal solution. So here you will see, suppose in some problem what happen when we adding AI and BJ, and some of these are not equal, right? Then this is called the unbalanced transportation problem. Then what we do? Suppose row wise or column wise deficiency, right? So depending upon this, you add either one row or one column, right? So this is called what? One row, one column, and give the whatever sufficient amount, either in availability or demand, right? Suppose deficiency is 5. Okay, so you write here either in demand or in availability 5, right? Then when we add one extra row or column, then there we need some cost, and this cost should be 0, 0. You will consider this is the rule for making balanced transportation problem. So second paragraph, you see, an unbalanced transportation problem is converted into balanced transportation problem by introducing a fictitious source or destination, means imaginary, source or destination, which will provide the surplus supply or demand. The cost of transporting an unit from the fictitious source or the fictitious destination is taken to be 0. After the converting the unbalanced transportation problem to balanced transportation problem, by the introduction of fictitious sources or destination, and it is solved by the earlier method. The earlier method means what? This one, same as if mentioned, solve it by lowest cost entry method, or solve it by northwest corner rule, or solve it by Vogel's approximation method. If not mentioned, then you apply Vogel's approximation. So this is the rule. It's one unbalanced transportation, how to convert one unbalanced transportation problem to balanced transportation problem. So this theory is clear, this theory portion. See, because sometimes ask question, 5 marks or 4 marks question. Okay, define unbalanced transportation problem, or write the how to convert unbalanced transportation problem to balanced transportation problem. Okay. Next, you see, suppose last problem in transportation problem, last class transportation problem, after using Vogel's approximation method, what we do, you see, number of allocation is what? You take any one example. I have given class. You take any one example, and after Vogel's approximation method, number of allocation is what? Suppose you see, one question I have given earlier last class maybe. A company has 4 plants P1, P2, P3, P4, from which it supplies to 3 markets M1, M2, M3. Determine the optimal transportation plan from the following data given, giving the plan to market, shifting cost, quantities available at each plant, and quantities required at the market, right? This problem I have given or not? Market and plant. First row is 19, 14, 23, 11. Second row is 15, 16, 12, 21. Then 30, 25, 16, 30, 39. You see whether given or not this problem. For this one?
Yes, sir, you are given.
Given. Okay. You see the example of this one. 9th December, I have given one problem related to transportation problem. Transportation problem I have given. So, after Vogel's approximation method or Vogel's method, you see table number 11.10. You see the table number 11.10. Here, number of allocation is what? Number of allocation. How many allocation here? Number of allocation in table 11.10. All of you see? টেবুল টু হল তোমার এই যে 11.10 টেবুল টু আসলে ফার্স্ট টেবল যোনটো দিছিল by Vogel's method. An initial basic feasible solution of the given problem is given by the following table. Means I already told you, first you will apply here Vogel's approximation method, then you will get the table 11.10. Okay, then in this table, number of allocation is what? Oh yes, Roshni, number of allocation is? Yes, 6. Oh, good. 6. You see
Six.
number of allocation, yes, 6. Allocation where you will get, here you see cell number 1 comma 4. Cell number 1 comma 4 means what? First row, fourth column. Allocation is 11. Cell number 2 comma 1. Allocation is 6. Cell number 2 comma 2. Allocation is 3. Cell number 2 comma 4. Allocation is 4. Cell number 3 comma 2. Allocation is 7. And cell number 3 comma 3. Allocation is 12. Okay. So here you see how many allocation? 6 allocation, right? And what is the value of here? M plus n minus 1. M plus n minus 1 value. So m plus n minus 1. Meaning of m here, m means number of rows, n means number of columns. Okay, so of columns here you see m plus n minus 1. What is the value? In this table, how many rows?
Six, three
Six.
rows and four columns.
Yes, 3 plus 4 means 6. 7 minus 1. Yes, 6. Okay, so here you see number of allocation is equal to m plus n minus 1 because number of allocation is 6 and m plus n minus 1 is also 6. So m plus n minus 1 is equal to number of allocation. Then this is the definition of whose definition? This definition is called what? Either 5th December or 6th December, like this I have given. You will see the definition. Few important definition. Then definition number 4, you will see in transportation problem. Non-degenerate basic feasible solution. You will see. Okay, non-degenerate basic feasible solution. So definition is what? A basic feasible solution of m by n transportation problem is said to be non-degenerate basic feasible solution if total number of positive allocation is exactly equal to m plus n minus 1. So here total number of positive allocation here 6 is exactly equal to m plus n minus 1. Okay, and number 2 point is what? These allocations are in independent position. I have given two table diagram given what is independent position, what is non-independent. Independent means we cannot make a loop from this allocation, we cannot make a loop, and non-independent position means we can make a loop from the allocation. Okay, and when we make a loop, should be we draw a line either horizontal or vertical, not in crossway. Okay, so this is the definition of non-degenerate basic feasible solution, right? So here you see all the problem solved. This is non-degenerate transportation problem. All the problems are non-degenerate transportation problem. This is clear. Non-degenerate transportation problem means what? Number of positive allocation is exactly equal to m plus n minus 1. So you see earlier all the problems number of allocation is exactly equal to m plus n minus 1. So clear this one? Non-degeneracy of transportation problem.
Yes, sir.
Okay, so you will see the definition, all the definition. kept in or copy, okay? You will not kept in your mobile this one. From here, daily class, whatever I have sent from your from PDF file, you will write in your copy. So next theory, why I have discussed this one, because next uh, theory is degeneracy in transportation problem. Degeneracy in transportation. If in transportation problem, suppose there is degeneracy, so how to resolve degeneracy? Sometime ask question in your exam, how to resolve degeneracy transportation problem. Means one degeneracy transportation problem to non-degenerate transportation problem. So when this is degenerate transportation problem, when number of allocation is less than or less than n plus n minus 1. When the number of allocation in degeneracy, when occur in the transportation problem, if number of allocation less than m plus n minus 1. So you see the theory. In a transportation problem, degeneracy occurs when the number of independent individual allocation is less than m plus n minus 1. Suppose for some reason you see earlier problem, you instead of 6, suppose you got 5 allocation, then what? 5 and m plus n minus 1 is what? 6, right? So then what we do? Then this is not the non-degeneracy transportation problem. This is the degeneracy transportation problem. So you see the theory in transportation problem, degeneracy occurs whenever the number of independent individual allocation is less than m plus n minus 1. And degeneracy may occur either at the initial stage or at an intermediate stage at some subsequent iteration. Right? In such cases, to resolve degeneracy, we allocate an extremely small amount, okay, so close to 0, to one or more empty cell of the matrix, generally lowest cost cell if possible. Because suppose after using Vogel's approximation method or any one method out of 3, after solving this, suppose we get the problem is degeneracy, means number of allocation less than m plus n minus 1. Then what we do? We give small amount, means extremely small amount nearer to 0. So we consider say delta. Okay, delta is positive number and which is small, which is very small, right? So delta greater than, here delta is very small but greater than 0, right? So we allocate extremely small amount to one or more empty cell of the matrix, generally lowest cost cell if possible. So in here you see lowest cost you will get. So we shall give lowest cost cell, we give this one. So that the total number of occupied, means allocated cell, becomes m plus n minus 1 at independent position. We denote this small amount by delta or epsilon, anyone we consider. So we consider say delta and satisfying the following condition. So conditions are what? Number 1 is 0 less than delta xij. Xij means quantity. Okay, so xij is always positive because suppose 1 kg, 2 kg like this. So 1 kg, 2 kg, this cannot be negative. So this one. So this condition number 2 point is delta plus 0 equal to delta equal to 0 plus delta, right? So this is same as the commutativity like this. Mm, means here like property of identity like this. And then number 3, xij plus minus delta equal to xij means what? Delta is very small number, so there is no effect when we add or subtract. Okay, these three conditions. And fourth one is if there are more than one deltas introduced in the solution. One point is if delta delta dash are in same row, then delta less than delta dash when delta is to the left to delta dash, and if delta and delta dash are in the same column, then delta less than delta dash when delta is above delta. And it is clear that after introducing delta satisfying the above condition, the original solution of the problem is not changed. It is merely to technique to apply the optimality test and omitted ultimately. Means what? After this, what? Sometimes what happens? Here 5 allocation and m plus n minus 1 is equal to 6. So here you see one deficiency. Give one delta, right? If number of allocation is suppose 4 and m plus n minus 1 equal to 6, then you see here we two del means two allocation. Two allocation means what? One is delta, another one is delta dash. So then this 4 number point is important one. If there are more than one deltas introduced in the solution, point number 4, then if delta delta dash are the same row and delta less than delta dash, when delta to the left to delta dash. And if delta and delta dash are in the same column, then delta less than delta dash and when delta is above delta dash. So this problem, you will see this theory and related this problem next class. I shall give the question, then this one will be clear. Okay, because you see sometimes what happen, degeneracy transportation problem is given. Solve the following transportation problem. So seeing the problem, you cannot identify whether this is degeneracy or non-degeneracy. First you apply means Vogel's approximation method. If not mentioned, then you apply Vogel's approximation method, and then you will get here allocation. Final table you will get allocation. After seeing the allocation, you will see here what will be the means m plus n minus 1 is equal to exactly equal to number of means what number of allocations or not. Okay, after this you proceed to optimality test, means we apply here optimality test, means Modi method you apply. Before optimality test we here apply what this, if the problem is degeneracy, we convert it into non-degeneracy. So this is clear or not, this theory portion, how to resolve degeneracy?
Yes, sir.
Okay. So you'll see the theory because 5 marks or 6 marks question asked. Write the degeneracy of the transportation problem. Earlier, all the problems are non-degenerate transportation problem. So, and in your exam, because in DCA syllabus, maximum given this is non-degeneracy transportation problem. Degeneracy for higher section, degeneracy apply. But I shall give one problem related to degeneration.
Present, sir.
Present. Aniket, Anuj, Arbaj, present. Arif,
Present, sir.
Asifuddin, Achyutananda, Bhagyoshri,
Yes, sir.
next Bhargav,
Yes, sir.
Binoy,
Present, sir.
Vishwajit,
Present, sir.
Daniel,
Present, ma'am. Present, sir.
Dijesh, Dimpy,
Yes, sir.
next Himanshu Ranjan, Vikas, Rishikesh,
Present, sir.
present. Ishita, present. Jonali,
Present, sir.
Jyotish Kumar, Keshav Pandit, Kunal Sarkar, yes,
Present, sir.
yes, Kunal, Madhurima,
Present, sir.
Manish, next Marconi, Nesnam Ritik, Mosam Bahar, Farid, Mehboob,
Present,
Sir,
sir.
present. Mehboob.
yes, next Mosami,
Yes, sir.
Turkey Raja, Nihal Kaushik, Pradyumna,
Present, sir.
next Prakash Sharma, Rahul Sharma, Raj Mitra, Ripon,
Present, sir.
Rohit,
Present, sir.
Roshni,
Present, sir.
Rupjyoti,
Present, sir.
Shahbaz, Sanjam Pranim,
Sir, Shabbos present.
Sanjam Pranim, Shankanath,
Present, sir.
Siddharth,
Present, sir.
Soumik,
Present, sir.
next Sudeep,
Yes, sir.
Sani, Tapan Taman, next Tirth Agarwal,
Present, sir.
next Vicky,
Present, sir.
Konkon Borua, Mosam Shekia,
Yes, sir.
Vikrant Nath, or anybody?
Sir.
Shankanath, yes.
No, from Thursday, your class will be at 10 a.m., sir.
From Thursday, there will be some means interchange here. I shall take from 10 a.m.
Okay, sir.
Okay, thank you.
Thank you, sir.
Sir, anything about college reopen? Anything about sir college reopen? Any information?
College, you will be intimate maybe last week of December or January. Okay, or first week of January.
Okay, sir.
Till now, not decided. Huh?
Okay, sir.
Sir, but law students are like reopening on around 16th of December, I heard.
16 December, na?